So let's have a quick look at the inverse square law. Now we've seen we have a power source here, this power generating into a sphere. Now obviously it's going to be very, very hard for me to draw a sphere here, so I've pasted this a very good drawing of how the sound power is being radiated. So let's take at a distance r, we have this 1 meter by 1 meter square here. So that is our intensity traveling through that 1 meter square there. But if we were to double that distance, you can see there's now 4 squares. And that's pretty obvious actually, because the surface area of a sphere is 4 pi r squared. So this distance r here, we've got an r distance there, r to 2r, is actually, it's going to be squared the surface area there. So yeah, we have. So if we double this distance, we get 4 times the surface area here. So there's actually 1, 2, 3, 4 times the surface area. If we go one further, so it's 3 times the distance away, what's 3 squared is 9. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 times the surface area, i.e. the power has now been spread over 9 times the area. So the intensity is going to drop by 1/9. So let's see how intensity changes over the doubling of distance. Well, it's obviously the intensity is going to be proportional to 1 over r squared. So it's proportional to that because this is a constant. 4 pi is just a constant. It's always going to remain the same. The only thing that's changing is this r term, and it happens to be squared. So as the distance gets further, we're losing r squared. So let's put that into our intensity equation, 10 log. And we've got remember, we've got this ratio of intensity measured over our intensity reference. What we're now going to do is, all we're trying to do now is try and find a ratio of what the difference between two things is. So if we put that ratio of r squared in here, so we've got twice the distance here, so 2, but there's 2 times, it's 2r, so we know it's 2 squared, so that's 4. 10 log base 10 of 4 is roughly 6 decibels. You can put it in your calculator. If we're going 3 times the distance, that's now 3 squared. So this number now becomes a 9. 3 squared is 9, and that is roughly 9.5 decibels. And if we were to go a little bit further to 4r, well, actually, that's nice and easy. 4, it becomes 16, so that's now 16 that we're trying to find. That is 12 dB. So in doubling the distance, we got a 6 dB drop. In quadrupling the distance, we got a 12 dB drop. And actually, if we went all the way out to 8 times the distance here, you would find that there was another 6 dB drop, and we would get to 18 dB. So it follows the inverse square law. Inverse square law, because of this pi r squared, is the formula for a sphere. So this only really represents what happens in a sphere. So the intensity is dropping by the r squared. So for every doubling of distance, it's a 6 dB drop. So we got a 6 dB drop here, and we got a further 6 dB drop here, and then obviously we've had to dotted lines in here because that's a lot further out, and there was another 6 dB drop between to 8r. So eventually we got an 18 dB drop over this huge distance, that's almost 20 times less intensity. So you can see that sound tails off pretty quickly.